using machine learning in testing?
Oh no, I didn't learn machine learning.
Or was it search-based testing? Remind me which project?
SSIT.
Let's have a look.
We don't have this method.
MSc project. Using search in software testing.
Yeah.
Okay, great. Okay, so the idea is it fits into an area people call search-based software engineering. And so the idea is you take a software engineering problem and you turn it into an optimization problem. And then you apply something like a genetic algorithm, some technique like that. It would be to take a software testing problem and describe it as an optimization problem, design and build a technique to solve that. So it's like a genetic algorithm or hill climbing or something, and then run experiments. So something like that. Tell me about your background. Do you know much about how's your programming? Do you know much about things like genetic algorithms?
When I was an undergraduate student, I did a project to set up a website.
Okay. Did you write much code as part of that?
But I didn't learn. When I was an undergraduate student, I didn't major in computer science.
Yeah. What programming languages have you used?
Java.
You've used Java. Okay, good. And you're happy with Java?
Yeah. This semester, we are learning Java.
Okay. And how are you finding Java? Is it difficult, easy?
I am interested in mathematics related skills.
Okay.
So I like Java.
Okay, good. So, shall I give you an example of a software testing problem? We just learned software testing in theory this semester. Yeah, absolutely. So I don't expect you to know much about software testing, so that's fine. So, but you can write programs and you'll need to learn about things like genetic algorithms. Software testing you don't need to know much about. I'll give you an example of a problem that people have looked at. Take this. You have a set of tests. And so, for example, many companies will have a set of tests for their system. And whenever they change their system, they run all the tests again. So this is something called regression testing, and it's standard practice. And so they have, an example is Microsoft, and every day they retest their systems, the latest build. They run all these tests. Now, if you take a company like Microsoft as an example, then their full set of tests is so large, it's incredibly expensive to run all of them. And it takes a long time. So they can't do that every time. They can't run all of them every time. So which ones should they choose? They've got 10 million tests, they only got time to run 1 million. So one thing you can do is you can say, well, here are some test cases. They're different inputs. And actually, these cover, if you look at a program, you might look at which parts of the program it goes through or covers. You might say, well, one part of the program is covered by these, and another is covered by those, and another is covered by those. We've got 3 parts of the program, and we should make sure we execute all 3 parts. So what's our smallest test suite that does that? Well, we need something in this set, we need something in this set, and we need something in this set. And we want as few as possible. Well, if we choose this one and that one, that's sufficient. So this part of the program is still executed because we kept that. This part is still executed because we kept that. And this part is executable because of both of these. So there are techniques that use, there's a number of companies that do this, that will say, okay, we can't run all our tests, but we want to ensure that we at least still test everything. And they know which tests test different parts, and then they find a smaller. Now, mathematically, this is related to something called a minimum set cover problem. So there are some mathematical optimization problems that this is very similar to. What this is saying is you want to find a minimum subset of the set of points such that every one of these contains at least one. Okay, so it's an optimization problem. And it's been addressed using genetic algorithms and hill climbing and other techniques. So that's one example of a problem that's very clearly an optimization problem. Another problem people have looked at is test generation. Suppose you have a piece of Java, and you look at the control flow graph. So you start, you go this way or this way. And here you go there, and here you go that way, or that way. And this is it's all down finishes. Okay, so these are different routes through the program. So it's a graph. And you say, I want a test case that goes through here. I haven't yet in testing executed this, which is like an if statement. This would be example, I've only executed the false case, I've never executed the true case for this if statement. So, what's the optimization problem? I want a test input that gets me as close as possible to following this path and then that's taking this. And you can describe that again as an optimization problem. And people have built automatic test generation tools that will produce test cases for Java, for example, code. You give it your Java code, and it returns test cases that execute all the parts of your program. And they do it by using this kind of technique. They come up with a nice description of how close a test input is to doing what you want, and then it says optimize on that. So there are a few testing problems that have been looked at in this way.
For example, if I do a project of website, I know I can use my SQL to create database, use Java to create background. I know what I'm going to do in general.
Yes.
For this topic, how to do I need to write a document use like a test case or?
What I would expect, okay, the project I think would go through the following phases. We would start off by looking, by choosing a testing problem. So there's two choices. Either choose a testing problem that hasn't been explored yet, or choose one that has and apply a different technique. So, for example, we could choose this kind of problem and say people have used genetic algorithms, but they haven't used simulated annealing, or they haven't used tabular search. So why don't we try doing that? Then it would be write some Java to build a prototype tool that implemented the technique, and then you'd run experiments. And possibly iterate, because you might then find it didn't work quite as well as you'd like, and then you go and improve. So it would be a initial discussion, which problem to choose, which I'm very happy to help with. and then it would be design the software you're going to build in Java, and then it's write the code, and then it's run experiments.
Actually, this project problem.
Yeah, these are examples.
So, I need to choose just one particular.
No, we can choose a different one. Up to you. We can have discussion. You will only choose one. And these are examples of problems you might choose, but there are other examples. And I would be happy for you to suggest there are other examples, or to choose one of these.
So I don't need to tackle all of this.
No. Oh, definitely just one problem. Absolutely. Oh no, that's too much. More than one would be far too much. So I would expect a problem like one of these. So there's some here, and there are 3 there, and there are others. Those are just examples. I'd be very happy if you chose one of these. I'd be very happy for us to think about other problems. Okay. Do you have any questions?
So, if 3 students choose this topic, so this project doesn't require us to cooperate with other students. No. I need to do this by myself.
Yes, that would be the intention, is that if 3 students do it, they will tackle different problems.
And where do I find the program that can be used in the test? I need to.
Okay, so that's a very good question. So it depends on the problem you're looking at. So if you were looking at this, then there are 2 things you could do. One is you could look at online software repositories that have test cases and code. So there are some real examples you could use. And the second thing is you could randomly generate examples. You could randomly generate some examples of these kind of things. And what a lot of people would do is do both. So you have a small number of real examples, and then you have lots of randomly generated examples. And that allows you to use things like say, well, as the problem size gets bigger, how does my technique scale? Does my technique still work well with big problems as well as small problems? So ideally there are some real examples, but it's nice to have lots and lots of examples, and that often means generating stuff. But for something like this, it's easy. You can see all it is randomly generate a set of subsets. It's not too difficult. Yeah.
I'm willing to try this project.
Okay, great. Okay, I'm happy with you too. If you're, yep, okay, great. I'll email admins to make sure they know that, and then beginning next week, I will probably email you about a couple of papers you could look at. There's 1 or 2 survey papers in this area, and I won't expect you to read all the paper because they're very long. But it'd be nice maybe for you to read the introduction and background or something like that. Okay. Okay. If you're happy with that, then yeah. Okay. Great. Thank you very much. Okay. Excellent. And the trick is, okay. Bye.